So maybe they are not available right now. So I will start the session, no worries, so that they can go through the recording, because I don't want to waste the time waiting long for everyone to join. I hope you can see my screen, right?
Yes.
Fine. So yesterday we discussed uh, about introduction to KiCAD, and I have shown you the PCB editor and the schematic editor, and we have added one resistor, and then we discussed about the automation using in KiCAD using Python language, Python scripting. So we discussed about the scriptable feature, right, which is there in KiCAD, but it is not there, absent in ECEDA. So today we will be discussing a few more important things. So basically today I will be showing you some demonstrations. Okay. So today, just to make you understand what are the different possibilities. So we can extend a long, okay, we can extend so many features with the help of Python. So I will be just demonstrating few of such examples. Okay. Yeah.
Sure.
So yeah. So this is the Automata folder which we have created yesterday. Okay. I hope you remember this folder, Automata folder, which we have created yesterday, and we are
Yes.
having a couple of different files. We are having a couple of different files inside this Automata folder. Okay. So each file, it is programmed in Python language, and which is having, it is having a specific role. So I'll just show you a few of such scripts. Okay, now we are having one is count.py file. Okay, count.py file. I will execute each and every particular file and I'll show you. Okay, so but before that, I'm just going to this particular file. Okay, the project which we created yesterday, MPU 6050, which is having the file extension .kicad underscore PCB. So that means basically I'm just navigating to the PCB editor. Okay, so I think let me just delete all the things. Yeah. So also let me just check the schematic if there's any unnecessary things are there. Acha, okay. So let me create a new project, and I'm giving it some name, Automata. Automata. Yeah. I'm going to the PCB file. Okay, I'm going to the PCB file. So this is the PCB for the new project, PCB editor, and I'll also go to the schematic file. Okay. So this is the schematic editor. So now what I will be doing is I'm just navigating to the Visual Studio Code editor. I'm going to the counter.py file. So don't worry about all this program. I will just give you a basic intro about this program. Yeah. Just give me a second. I'm getting an important call.
Okay, okay.
Hello. I'm in class. I'll just call you back later. Yeah, yeah, yeah. So right now I'm in counter.py file. So basically here I'm just see this is the path, okay, for the project. So every project it will be presented some particular location, right? So inside our system. So first you need to identify at which particular path the project is located. Okay, at what directory, at what folder all your projects are being saved. Whenever you create a new project, first you need to identify at which location all these new projects are being stored in your system. So there are different ways through which you can identify that. So here there is a preference option. Go to the preference and click on configure paths. So basically we call these names, we are having some table, right, name and path. So these particular things we actually call them as the environmental variables. Okay, all these are environmental variables. So here you can see this is the directory where footprints are there. So this is a directory where 3D models are there. Third party related files are stored in this particular directory. So yeah, so whenever you are creating a new project, it will ask you to choose the location. Yeah, someone trying to join the meeting. Yeah, are you? So whenever you are creating a project, it will ask you to choose the location, right, where you will be storing that project. So I'm just see, I'm just right clicking on that particular PCB file and I'm just clicking on edit in a text editor. Okay, so automatically it will be showing you your folder, right? Automata. So I'm just going to the automata, or else you can copy the right click on it and you can just copy the file path. Okay, yeah, or else you can just KiCAD, and this is the automata folder. Okay, so in the automata folder we have created some scripts. Okay, got it. So MPU 6050, and I think we have created one more project, right now. What's the name of the project? It's Automata. Open directory in File Explorer. It will directly take you that particular. See, you do one thing. So just click on this dot KiCAD underscore pro, right click on it, click on open directory in File Explorer. It will directly take you to the location where you have stored this particular, where you have saved this particular project. So here we are having couple of files. This is project file, this is board PCB board file, this is the schematic file. So now what I'll be doing is I'm just right clicking on it. Okay, right click and copy as path. So I'm just going back to I'm just replacing this particular uh, file path with the latest one. So I don't worry, I'll explain you the Python script as well in brief. Yeah, now what I'll be doing is, so I'm just going to the command prompt. Okay, not the normal command prompt, KiCAD command prompt. Okay, so inside the KiCAD command prompt, first I need to navigate to the folder where I have created this particular Python scripts. See, actually, I'm storing my projects in some other location, and I'm storing these Python scripts in some other location. Okay, it doesn't necessarily that you need to follow the same thing. You can store wherever you want. So due to some memory to manage them, my C drive is already full, so that's why I'm storing in G drive. Okay, so first what I will be doing is I'm just navigating to that particular folder where I have created these Python scripts. So I have created these Python scripts inside, inside the G drive. I'm having the KiCAD folder. So inside the KiCAD folder I have created a new folder, automata. Inside automata all these are Python scripts which I have written manually. Okay, all these are Python scripts. See, Python source file. Yeah, all these files are Python scripts. Okay, now what I will be doing is I need to navigate to this particular directory. So with the help of the command prompt, so for that I will be passing this command cd backspace d. So I think it's a G drive, or else I can, okay, you can directly copy the file path as well. Copy as path, go to the command prompt. So here you can paste the path. Yeah, just hit enter. Now it will take you inside this automata folder. Now I will be running one Python script. Okay, python space python space count.py. So now see, it returns some result, right? Board component summary. So this is a particular PCB board, okay, which we have analyzed. So we have performed one operation which is nothing but count operation. So basically we are trying to count the number of components which are there in the PCB with the help of the Python script. So is that clear? So basically this count.py file which I have created, the Python script, is programmed in such a way that with the help of a pcbnew library, so we can able to uh, count the number of components which are placed in the PCB. See, actually this particular automata PCB file, this is actually a newly created project. So by default when you create a new project, it comes with, no components will be pre-existing in a schematic file, right? So that's why it is returning zeros, all zeros. Okay, now I will show you in practical, like I will show you in demonstration. Now I will be doing one thing, I will add a resistor. Okay, let's see if a Python is really able to calculate the number of components which is present in the PCB or not. Okay, I will be just going to the PCB editor. I'm going to the place option. uh, okay, or else first I will go to the schematic editor. So in the schematic editor I'm going to the place. See, this is the biggest advantage in KiCAD. We can run Python scripts, we can run Python plugins, and we can do a lot of interesting stuff. So now what I will be doing is I will be placing something like a resistor. For that I need to I need to enter R. Okay, or usually if you press R it will show you, or else you can type a resistor. Let me open it again. Place symbol. Yeah, I'm just typing R. Yeah, I got a resistor. I'm hitting enter. So I will be placing a resistor in schematics. Yeah, I have placed the resistor. So what I will be doing is I will be assigning some value to this resistor. Okay, yeah, but before that we'll do one thing. Before assigning the value, I'm just going to the PCB editor again, and I'm going to update the PCB from schematics. For that you need to go to the tool section, click on update PCB from schematics, and click on update PCB. But now actually you have added a resistor in the schematic section, but even though you click on update PCB, this resistor will not reflect in the PCB editor section. Okay, so I'm just clicking on update PCB. See, I'm just closing it. So do you find any resistor in the PCB editor? So now my question is, why do you think so? Even though we have added a resistor in the schematic section, so when we try to update the PCB from schematics, so why is it not actually placing a resistor in the PCB editor? So you have performed a similar operation in ECEDA. In ECEDA, if you place a resistor and if you just go to the PCB and just click on design and go to update PCB from schematics, automatically that resistor will be appearing in the PCB editor. But the same here, it is not happening. So what do you think the reason could be? Any idea, Sri Krishna, why it is not reflecting? The resistor is not being updated in the PCB editor.
Because I mean like it. If we make any circuit, not only rather than a single component, it will reflect.
No, no, no. So no matter even you are having a single component or many components, so connectivity is optional. Okay, here we should not take that into consideration. So if you are placing see any PCB editor, if you place a component, if you update the in schematic, if you just click on update PCB from schematic, so ideal behavior that we expect is that it should reflect in the PCB editor. We should fetch the components from uh, schematic editor, and it should display, it should reflect in the PCB editor, because the particular option update PCB from schematics. Okay, so the aim of that particular tool is to fetch the components and update those components in the, or else whatever the changes that you did in the schematic to update that in the PCB. So that's not a valid answer. So any other guesses, any ideas, Sri Krishna, any other guesses?
No.
Yeah, so that's why it's essential to understand. So if you learn one particular PCB design software and you think that yeah, I'm able to do PCB design, so no, that means you are in ignorance. So if when you know, when you just work on multiple PCB editors, multiple PCB designer softwares, then you will come to know how the user interface is changing, and how it is functioning. All these things you will come to know. Okay, sometimes certain tasks that you performed in one editor may be valid, but the same approach may not work in different designer tools. So maybe you need to follow some other approach. So that's how you need to understand. Whenever you just learn multiple PCB designer tools, then you will be able to understand how these user interface do work. Okay, so here actually the thing is, uh, there is something called assigning footprints. Okay, placing a component, just barely placing a component in the schematic editor. See, if I just try to, again I will show you, it will display, actually it will show you an error to you. When you try to update the PCB from schematic, it will return an error. See, so it is already showing changes to be applied. So already detected that, the PCB editor already detected that there is a resistor, or there is a symbol which is having the reference designator R1. Okay, but it is also returning an error that cannot add R1 because no footprint is assigned. Because no footprint is assigned. So we need to assign the footprint, then only you can able to add that particular component into the PCB editor. So how to assign the footprint? So for that you need to go to the tools, and in the tools section in the menu, you can find one option called assign footprints. Click on assign footprint. So when you click on assign footprint option, automatically it will show a huge list, okay, of all the components which are there in your PCB. I mean in the schematics. Okay, not in the PCB, in the schematics. So if you are having only one component, it is expected that it will show only one component. See, I hope you can see R1. It is showing the R1. Okay, this is the designator. So now here, you need to assign the footprint. Okay, for that, here you need to search the footprint. Okay, let's say, see, resistor can be the through hole resistor. See, resistor, there are so many types. Okay, based on dimensions. Okay, based on different parameters, we are having different footprints. So I'll show you. If you type resistor, see, so many things you are getting. Okay, see, but how to select the correct one? So just right click on that, and you will be having one option, view selected footprint. So before assigning a footprint, so you can also check the footprint. Okay, this is the footprint. Okay, so like that you can just check out the different footprints. The matching footprint, you can go with it. So let's say, see, all these are SMD. I'm sure that you know what is SMD, right? So similarly, if you want to place a THT, just type resistor THT. See, all these are THT. That means through hole. All these are through hole resistors. See, through hole resistor. So different things are having different footprints. Okay. Okay. So let's say I'm going with this particular one. Okay, I'm just clicking on So to assign this particular footprint, first you need to double click on this. Okay, first select the R1 and then double click on the particular thing that you want to assign. See, now it is showing. Okay, that means you have assigned this particular footprint to the resistor, the particular component. But that's not all. You need to click on apply save schematic and continue. Okay, you need to click on apply save schematic and continue. Then click on OK option. Okay, then save the file using Control S. Now go to the PCB editor. Now again go to the tools and click on update PCB from schematics. Now again click on update PCB. Now resistor will display in the schematic. See, now I am able to see the resistor. Okay. Now I am able to see the symbol. This is the footprint that we assigned. Okay. So I'm just clicking on Control S and then I'm going to the view. In the view, I'm just going to 3D viewer. So there is a shortcut key. You can also go with Alt plus 3. See, it is only showing that particular part. Okay. Yeah. So it is only showing that particular part. See, this is the footprint that we have assigned. So, but see, actually, it is not actually rendering the PCB very properly. Okay, it is not actually rendering the PCB very properly. See, this is also one form of resistor. Okay, this is also one form of resistor. So I will show you how to change the 3D model. Let's say you want to place some other, some other kind of resistor. You can do that. I will show you that in the upcoming session. How to change, the 3D model. Everything we'll be having separate session on 3D modeling. So now what I will just want to show you, demonstrate you is that. So I want to demonstrate you these components can be accessed by the Python. Okay, I'm just running the same command again in the KiCAD command prompt window. Python count.py. See, now it has written something. See, SMD components 0, through hole components 1. Just now we added one through hole component, right? So now it is showing quantity, I mean the serial number 1, and this is the value R, and this is the footprint. Okay, that we assigned. See, we can change the value of the resistor also. For that, you need to again go back to the KiCad. For that, you need to go to the schematics, double click on this. It will show you edit reference field. Okay, sorry. Just double click on the component or single click is fine. It will show you the properties. Here you need to, uh, yeah, double click on that. Now here you need to change the value. Okay, let's say I want to assign 10K. That means I just want a 10 kilo ohm resistor. So change the value, click on OK, Control S, go back to command prompt. Let's check again if it's updated in the Python script or not. So I think we need to save the file again. Yeah. See, actually we have, okay. So this is, see, I just again saved the file. Again, I will run the Python script. Now, what actually we expect is that it will change the value over here. Okay. Instead of R, it is expected that we'll get a 10K as the value. So, but actually, in fact, when I again execute this program, so again I will get the same thing R instead of 10K. See, I'm getting 10K. No matter how many times you execute, I'll get same thing. I'm just clearing my screen with the CLS command. Again, I will execute the same thing. I'm getting R. So now, what do you think the reason could be? Why am I getting R instead of a 10K? Why am I getting R? I have already updated in the schematics. Still, it is only showing R. What do you think the reason could be?
I think you said how because you have not saved it, that's why it didn't change.
Sorry, can you come again?
I think you said all because you have not saved it,
No,
so
no.
that is why
Right
it
now I have
didn't
already
change.
saved the file. Already the file is saved. But still, again, if I run the
Okay,
Python script, it is returning R instead of 10K.
so I don't know the reason why it's not changing.
It might be because R is stored as a value through the footprint.
No, no, no. So actually, the thing is, whatever the library that we are using in the Python script, I will show you that library. Okay. So this is the library that we are using. Okay. Import pcbnew. You can see that library name, right? Give me a second. So this is the library which we are using in the Python script, pcbnew. So as the name suggests, so this pcbnew library can access the pcb file only. Okay. So again, see, here we have passed one path, right? So can you just remember what this particular path belongs to? Which file is it? Belongs to the schematic file, or is it belong to a project file, or else the pcb file?
PCB.
Yeah, it's a PCB. How to identify that? Because it is having the file extension KiCAD underscore PCB. If it's a schematic file, then it will be having the SSH, sorry, SSH as the file extension, but it is having PCB. That means it is a PCB file. So this PCB new library can access PCB documents only. Okay, we have updated in the schematic editor, but we have not yet updated in the PCB editor. So that's the reason why we are not getting that in the, see, again I'm going to the PCB editor. Now what I'll be doing is I'm just going to the tool section. I'm just clicking on, you can alternatively can click on F8 option as well. Now what I'll be doing is I'm just clicking on update PCB from schematics. Again update PCB. So now it, see, earlier here there is R. Okay. Though you have already modified the value of the resistor in the schematic editor, I mean in the schematics, you haven't updated that in the PCB. Okay. So the Python script that we are using right now with the help of pcbnew library, so it is actually fetching, it is actually it is actually analyzing this pcb document only, not the schematic document. So that's why earlier we have not updated the pcb from schematic, so that's why it returned R only, because it is already stored as R in the pcb file. So once you just click on update pcb from schematics and update pcb, you save this particular file. Again run the python script. Now it will we can expect 10k as the response for value. See, now it is showing 10k. So is this clear, everyone? So now this PCB new library is it able to access the
Yes.
schematic file, or is it able to access the PCB document? Simple question.
PCB.
PCB document, not the schematic file. Okay, so that's why whatever the updates that you do, the that you perform to the PCB document, they will be reflected when you execute that Python script, Python plugin. So those the data which is provided, it will be actually fetched from the PCB document, not from the schematic document. So this is very important, essential to understand. Okay, so that's why, because some people may think that I have updated in the schematic and you run the Python script, it is not returning because you haven't updated it in the PCB document. This particular this is actually a library. Okay, PCB new. So now my question is, do you need to install this PCB new library, or will it come by default when you install KiCAD on your system? Ayub, any idea? Do you think this PCB new library, do you think will it come by default when you install KiCAD application on your system, or you need to externally again you need to download it with the help of pip install PCB new or some other command?
No, no idea.
So actually it comes by default. Whenever you install KiCAD application on your system, so during that time only, during the setup process, it will also install some uh, dependency files, out of which this particular KiCAD-Python or PCB new is also part of it. Okay, it's actually part of the core files, core dependency files. So again, no need to install it externally, because it comes by default. Whenever you install KiCAD, by default this PCB new library is also installed on your system. So now we will be utilizing this PCB new library. Okay, see, actually before this session, your your ideology is like, we need to do, we cannot, you might not be aware that these PCBs can be modified with the help of a Python script. Okay, but after enrolling, after going through these our curriculum, now you will be able, now you are now you understood that even a PCB document can be edited with the help of a Python script. Okay, so for that, we will be, the library that we are using right now is the PCB new library. Okay, and we have written some couple of code which will be calculating the number of components, and it will be displaying in the command prompt. So I will show you a few other things as well. I'll show you a few other things as well. Now I'm having mm, one more Python script with the name image advanced.py, img advanced.py. So basically what I will be doing is, so I'm here, this particular file directory, I'm having a logo. Okay, I'll show you that. See, I'm just copying that particular file path and I will open that in the browser. Okay, see, so that means I'm having a logo in that, inside the desktop extras folder IITM. So inside the IIT Madras folder I'm having one logo. Okay, the Suchana logo. So now I want to place this logo. So I'm sure that you know how to place an image in ECEDA, right? We have already we are having a separate session on image operations, how to place an image, rotate, how to rotate an image. So all these things we discussed in ECEDA. So similarly, manually you can place an image in KiCAD as well. Okay, I will show you that later in the upcoming session, how to place an image manually in KiCAD. So now what I'm just trying to demonstrate you is, so with programmatically, with the help of Python program, you can programmatically place an image into the PCB editor. Okay, you can programmatically place it. So that's what I just want to demonstrate you right now. And I'm going to the Python script. So I'm just changing auto meta. Yeah. So this is the PCB document. Okay, PCB file URL or its path, absolute path, and this is the absolute path of the image file which I'm trying to place it in the PCB editor. I mean in the PCB document. So yeah, I'll show you. I'll run the code. So what I'll be doing is, instead of a counter.py, I'm running img advanced.py. Okay, so but before that I just want to show you the schematic editor, sorry, the PCB editor. So this is our present PCB editor. Okay, only we are having the footprint of the resistor. Now after executing the program, my expectation is that I should see an image over here somewhere else at some position. Okay, the position at which this image to be inserted is uh, it is mentioned. Okay, it is passed to the function, okay, pcbnew library in the Python script. It is specified in the Python script, okay, Python program which I have written in the VS Code editor. So for demonstration I will be just running, I will be trying to execute this Python program from the KiCad 10.0 command prompt. Okay, I'm just hitting enter. Okay, I think looks like I got some error. PCB new has no attribute PCB bitmap. Okay, let me check. Okay, so I'll be doing one thing. Actually, there's some mistake in that image advanced.py script. So that's why I have written one more script, that is pretty.py. Okay, I'm sorry, this is actually an incorrect file. Yeah. So here I will be doing one thing, automata dot. Yeah. So now instead of, now I'll be trying to execute this particular Python script. Okay. So I'm just passing the command python pretty.py. See, I will be showing you the PCB editor before executing the command. So I'm having only the footprint, okay, footprint of the resistor. Now after executing the program, this pretty.py, it is expected that an image, a Suchana logo to be displayed in the PCB editor. I'm just hitting enter and let's see the output. Mm, generated footprint. Okay, let me close the PCB editor and open it again. Automata. Okay, so it is returning none for board, right? Yeah. So that means the path that we have passed for PCB file, so it seems to be incorrect. So we need to check the path of the PCB file. So to do that again, first we need to go to the right click on this, click on open directory in file explorer. So right click on this and copy the absolute path and go back to the here, and you can try changing this particular path. Yeah, see, as you can see, I think the path is different, so that's why it returned none. So again I will be executing the same program. So it generated footprint and it returned successfully placed some logo on PCB. It is also returned some position x and y coordinate 100 mm comma 100 mm. So now we will just go back to the PCB editor and let's check. But if you go back to the PCB editor, you can, you don't find any kind of logo placed in this PCB editor. But the command prompt still shows, when we execute the Python script, it shows that successful image is placed. So what do you think the reason could be? Any idea? So why do you think the image is not display, not being reflected in the PCB editor, despite we have executed the Python script and we have it returned a successful message, but still we cannot find any such kind of logo inside the PCB editor. Any idea, Sri Krishna? Any idea?
Is the Python code, I mean, like in the PCB underscore PCB?
Can you repeat?
I mean, like previously we have saved in the schematics, but in the PCB editor we have the Python code, right? Like the same problem.
Yeah, but here we haven't done anything in the schematic, like to update from schematic. If you did any modification to the schematic, then you need to update PCB from schematic, but we haven't yet modified anything. So with the help of Python script, what we are trying to do is, like, we are trying to place an image in the PCB editor. So here we are directly modifying the PCB editor, because that PCB new library is now access. It is having all, capabilities to modify or to analyze a PCB document. Here we are directly trying to modify the PCB editor. We are no mediator, no schematic mediator. See, actually, to understand this, first you need to know complete documentation about PCB new library. So unless you know about PCB new library, it would be very difficult for you to understand why it is not being updated in the PCB editor. So actually there would be one function called as refresh function. Okay, there would be one function called refresh function. I will show you. PCB new dot refresh. I think board dot refresh. Yeah, PCB file. Okay, so image. Yeah, so there would be one function called as board dot refresh. So there would be one function called board dot refresh. So if you use this function, then only automatically it will be updated in the schematic editor. But in what we need to do if we don't pass the refresh function? So in certain circumstances, when you don't try to refresh it forcefully, then what you need to do is you simply just need to close the PCB editor. Okay, I'm just closing the PCB editor, and again I'm trying to open the PCB editor again. Okay, I'm just going to PCB editor. So this time you can find the Suchana logo showing being reflected in the PCB editor. So I haven't done anything. I haven't modified any code. Okay, I haven't modified any code, and I haven't passed any kind of command in the KiCAD 10.0 command prompt. Nor even I haven't modified the schematics or the PCB editor. I just simply close the tab and again open. Again, I try to reopen the PCB editor. So but this time when you again reopen that file, automatically you can see this particular logo. Okay, so earlier when you have joined the EC area course, that time you learned how to place an image manually in the PCB editor. So I hope you still remember how to place that image manually in EC area. But here in KiCAD we can use Python plugins, and we can with the help of Python script you can automate this particular thing. Okay. So the only one thing why it is the image is not updated is that the reason behind this thing is we haven't used the refresh function. There would be one refresh function. If you use that refresh function automatically without even closing and reopening the PCB editor, automatically all the updates, all the modifications that you performed with the help of Python script will automate immediately get reflected into the PCB editor. But if you won't use that refresh function, then you need to close the PCB editor manually and again try to reopen the editor. Then you can see whatever the modifications that you performed with the help of Python script and the scripting functionality and the Windows 10, KiCad 10.0 command prompt. Once you reopen, then you can find all the modifications. Okay, is that clear, everyone? Is that clear? Are you? Is that clear?
Yes, it is. Let me say partially, but I believe the record will be sent so that I can go through it again and again.
Yeah, yeah,
Because I
sure.
will need to practicalize it to be sure of myself whether I get it right.
Yeah, yeah, sure, definitely. The session is being streamed in the YouTube, I think so. Let me check. Yeah, the
Okay.
session is being streamed in the YouTube. As soon as the session is ended, we will share you the YouTube stream recording. You can go through that and you can just uh, try to build the same scenario within your system. Okay, but for that
Okay.
actually you need to have this script, Python script. So I'll do one thing. I will ask our team to post this Python script in the group. Okay, so that you can
Okay.
place the same script and try to execute this Python script from this particular command prompt. And already do
Okay.
remember, see, don't go with the direct command prompt. We'll be having a default command prompt which comes with the system. Don't execute this Python program with the command prompt nor with the PowerShell. Okay, nor with the Windows PowerShell. You need to execute this program only with the help of KiCad command prompt. Okay, this is a specialized command prompt for executing the Python scripts dedicated
Okay.
to the KiCad application. Okay,
Okay.
yeah.
Okay.
So now I will be showing you
Okay.
one more thing. So last time we have tried to count the number of components which are there on the PCB. Now we'll do one thing. We will try to again execute the same count.py file. Let's see what will happen if we again execute count.py. Now it return two things. The first one is the logo that we have added. Okay, and the second one is the resistor that we have placed. You might wonder why it is showing IITM, because this is actually specified in the Python script. Okay, yeah, here we have specified IITM logo. If you specify some other thing, it will show the same thing. Now you can see it is showing two different things. Now we will try to place one more resistor and let's check uh, if it is being shown in the command prompt or not. Yeah, I have placed one more resistor. Okay, now this time I will change the value from 10 kilo ohms to 100 or else 1 kilo ohm. Okay, now I'm having R2 resistor 1 kilo ohm. Okay, now I'll be doing one thing. I will be again running the script. So now instead of I'll ask you the question, like, do you think will it be showing the 1 kilo ohm resistor in the table? You think so?
No.
No. Perfect. Because we have updated in the schematic section, but we haven't updated it in the PCB editor. Unless you update in the PCB editor, it is not it is not gonna be reflected in the command prompt. So just to reconfirm this, again I'm just hitting enter button. Let's see if a 1 kilo ohm resistor is being shown in the table or not. Okay. See, so this is for your reconfirmation. Now what I will be doing, I'm just trying to update the schema. I will be trying to update the PCB from the schematics. So how to do that? Go to the tool section, click on update PCB from schematics. Update PCB. Now I have added one more resistor. Okay. Now what I will be doing? Again I'm just going back to the command prompt and again I will re-execute the program. This time it is expected that in the table we will be also getting 1 kilo ohm resistor as well. So as you can see, 1 kilo ohm resistor is now identified. Yeah, I hope it's clear, right? Can just quickly react with thumbs. Yeah. Okay. So now I'll show you a few other Python scripts as well. So we are having okay. So now what I will be doing is I want to draw outline to the PCB. Okay, I want to draw borders outline to the PCB. So I hope you remember how to do that in ECEDA, right? How to draw outlines of a PCB. So there will be an option where you can change the dimensions of the PCB, the length and height. I mean the length and the width of the PCB, and the material to be used. You can there is a drop down option. You can choose FR4 material, or else among a list of materials you are allowed to choose any one of the material. We discussed all these things. How to draw border outlines for a PCB. Okay, so again in the tomorrow session we will be seeing how to do this manually, how to draw outlines of a PCB. I mean, uh, whenever I refer outlines of a PCB, it refers to the dimensions of your actual PCB that you are trying to fabricate. Okay, now what I will be doing is, with the help of Python script, I am just trying to check if the Python is able to draw these outline borders automatically or not. Okay, with the help of Python script, I'm just trying to invoke the outline border, and I'm just trying to reconfirm in the PCB editor if it's really being updated in the PCB editor or not. So I have already pre-programmed one Python script. Okay, outline.py. So here I just mentioned all the dimensions, board dimensions, height of the PCB, width of the PCB, and two coordinates, x and y coordinate. We will there is a separate session where we'll be learning about how to understand these coordinates, ordinate and abscissa, if you in the PCB editor. So there is a separate session in which we will be discussing all those stuff. Now what I will be trying to do is, like, now I'm trying to execute outline.py file. Okay, and let's see how the output would be. Okay, so I'm just passing the command python outline.py. So but before that I will show you the PCB editor before executing the command. So this is how your PCB editor is being rendered before executing the command. Now I'm trying to execute the command. I'm just hitting the enter. So it returned, yeah, just give me a second. I have not yet modified the project directory. So it is, this path belongs to some other project. Yeah, again I'm just executing the same command. Yeah, so in automata.kicad underscore PCB, it has successfully drawn outline of dimension 80 mm into 80 mm. Okay, because we have specified 80 mm in the program, 80 mm into 80 mm. And the border outline, the drawing of the border outline should begin from the coordinate 40 comma 40. Okay, all these dimensions are in mm. Now I'm just going back to PCB editor. See, again no outlines shown here because we haven't used the refresh function. Okay, in the upcoming session we will use the refresh function and we will demonstrate as well. But as of now what I will be doing is, I'm just closing the window. I'll again go back to the home screen of the PC KiCAD application. I'll go to the PC beta and I will just recheck if the border outlines are being reflected or not. See, this is the border outlines which we have drawn with the help of Python script. This thing you can also manually do this. Okay, you can also manually draw the border outlines. Okay, so now I'll just moving these components within the borders, because if a component is outside the border, outside the outlines of a PCB, it will return a DRC error, design rule check error. So to make sure that no DRCs happen, it should be within the borders of these, within the walls, within the outlines of this particular border that we have drawn. Okay, so I'm just going to the 3D orientation. For that, click on view option, go to 3D viewer, and the shortcut key for the 3D viewer is alt plus 3. So I'm just going to the 3D viewer and let's see this PCB in 3D version. Okay, so now in the 3D version, if you see, this is the basic thing. We haven't added any component like resistor, capacitor, no circuit diagram, nothing. So just a basic thing. See, now these dimensions, okay, whatever the dimensions that this particular PCB is having in 3D visualization, these dimensions exactly match with whatever the dimensions which we prescribed in this particular Python script. Okay, see, as you can check, 80 into 80. So geometrically it represents a square, right? Because length and breadth, so both are equal. So geometrically it refers to a square. So if you check this PCB, it is perfectly in square shape. Okay, That's how this is a quick confirmation to identify whatever the dimensions that we have provided in the Python script. They are accurately updated in the PCB document. And these are the two resistors that we have added. If you don't want to see this 3D model, here there would be an option to disable the 3D models as well. These are the two footprints that we have added. Okay. So this is today's session, and today we discussed a lot of things, useful insights, how to access, how to count the number of components with the help of Python script. So we'll be going a little bit in detail, but not completely in detail, because if you want to learn automation of a PCB designing with the help of Python script, or if you take Altium Designer, see again, if you just switch to Altium Designer, the entire movie changes. Here we'll be using Python script, but there in Altium we'll be using uh, a variant of Pascal language. So Pascal is also one kind of language. So not completely we'll be using Pascal language, but a kind of variant which we usually call it as Delphi script. Okay, we'll be using Delphi script in Altium Designer to achieve these same tasks in Altium Designer. We'll be using Delphi script. See, this is, you can find the documentation about Delphi script in Altium official website as well. Okay, actually my device memory is currently out of, because I already am running KiCAD, right? It consumes lots of memory. So you can just check it out later. So just go through the Delphi script as well. So in Altium Designer, we will be using Delphi script to run again these same kind of, to achieve the same tasks. Yeah. So I hope today's session is clear and informative. And today we learned so many useful things. And by the way, this is Hemant, your expert mentor from Suchana. And this course is powered by Suchana Space Expo in collaboration with Groyota LLP and our special partners Anu Electronics, Ergal Technologies, and Luna Energy. So stay tuned for the upcoming session where we'll be discussing a lot of interesting stuff and automation with Python designing. Thank you for enrolling into the course. This is your expert mentor Hemant from Suchana signing off.